What if everything you think you know about the universe is just the opening chapter of an epic story still being written? Right now, forces beyond our wildest imagination are shaping realities we can barely comprehend: black holes bending time like putty, stars being dismantled for energy, civilizations engineering entire galaxies. This isn't science fiction. These are real possibilities waiting in the cosmic timeline, some unfolding over billions of years, others already set in motion. Today, we're pulling back the curtain on 45 astonishing futures for our cosmos, each more profound than the last. You'll witness stars reborn as celestial power grids, dimensions unraveling and stitching back together, even universes giving birth to new universes like cosmic Russian dolls. By the time we're done, the night sky will never look the same to you again, because you'll know it's not just a static backdrop, but a living, evolving entity with secrets we're only beginning to decode. Picture the last flickering candle in an infinite void. That's the fate awaiting our universe in this first vision. Scientists call it the heat death, a slow but unstoppable unraveling where every star exhausts its fuel, every black hole evaporates, and even the fabric of space itself grows colder than absolute zero. The culprit: entropy, the silent force that turns order into chaos, leaving no energy left to power even the tiniest motion. But here's where it gets fascinating. This isn't just doom and gloom. The laws of thermodynamics that predict this icy end might also hide escape routes. Some theorists suggest civilizations billions of years ahead of us could manipulate quantum vacuums or harness dark energy to reignite dying embers of reality. Others speculate about tunneling into newborn universes through black holes, like cosmic arcs sailing toward a new beginning. While the heat death remains the most likely finale for our story, it's also the ultimate challenge, one that might inspire beings of the far future to rewrite the rules of existence itself. Now, let's turn to an even more cataclysmic fate, one that doesn't just freeze the universe, but rips it apart atom by atom. Imagine dark energy, that mysterious force pushing the cosmos to expand faster, growing so powerful over time that it overcomes every other fundamental force in existence. First, galaxies would be wrenched away from each other, disappearing into isolated voids. Then stars would be torn from their orbits, planets shredded like tissue paper. But the horror doesn't stop there. As the acceleration reaches its peak, even the very fabric of matter unravels: molecules, atoms, and eventually the nuclei themselves splitting apart in a final, violent instant. This is the Big Rip, a finale so brutal it makes the heat death seem almost peaceful in comparison. The key factor here is dark energy's behavior. Does it remain constant, or does it intensify as space stretches? Current observations leave the door open for both possibilities, but if the terrifying phantom energy model holds true, the cosmic clock could be ticking faster than we think. Some calculations suggest this endgame might play out in as little as 22 billion years, a blip on the universal timeline. Yet there's a twist: our understanding of dark energy is still in its infancy. What if future civilizations discover a way to neutralize or redirect it? Could quantum entanglement or higher dimensional physics offer loopholes? While the Big Rip remains a real possibility, it's also a reminder that the universe's fate isn't set in stone, at least not yet. For now, it stands as one of the most dramatic and unsettling finales the cosmos might have in store. What if the universe, instead of tearing itself apart or fading into frozen darkness, reversed course and came crashing back together in a spectacular finale? Enter the Big Crunch, the dramatic cosmic reboot where expansion halts, gravity takes the wheel, and every galaxy, star, and atom is pulled toward a single, searing point of infinite density. It's the ultimate cosmic reset button, a scenario where the universe's fate mirrors its fiery birth in the Big Bang, but in reverse. This collapse isn't just a destructive ending, it could also be the seed of a new beginning. Some physicists propose that a crunch might trigger another Big Bang, birthing an entirely new universe in an endless cycle of expansion and contraction. The idea of a cyclical cosmos isn't just poetic, it's grounded in theories like conformal cyclic cosmology, where the death of one universe feeds the birth of the next, like a cosmic phoenix rising from its own ashes. But does the evidence support this rebirth scenario? Right now, observations suggest the universe's expansion is accelerating, not slowing, making the Big Crunch seem unlikely. Yet the mysteries of dark matter and dark energy leave room for surprises. Could gravity's pull eventually overcome dark energy's push? Or might quantum corrections or unseen dimensions alter the universe's trajectory billions of years from now? Beyond the physics, the Big Crunch raises profound questions. If the cosmos truly repeats, does each cycle replay the same events or spawn entirely new realities? Could information or even consciousness somehow persist across cycles? While we may never witness this grand finale, the possibility alone reshapes how we see our place in the cosmos, not as a fleeting moment, but as one note in an eternal symphony of universal rebirth. Among all the ways the cosmos could meet its end, none is as swift or as strangely beautiful as vacuum decay. Here's the chilling premise: what we call empty space might not be truly empty, but teetering on a fragile quantum ledge. If a single tiny region of the universe slipped into a more stable state, a true vacuum, it would unleash a bubble of rewritten reality, expanding outward at light speed. Every law of physics inside that bubble could change instantly. The speed of light, the strength of gravity, even the behavior of atoms, all might be different, leaving our familiar universe as nothing more than a memory. The unsettling truth: this isn't just speculation. The Higgs field, which gives particles their mass, exists in a state physicists call a false vacuum, like a marble resting in a shallow bowl instead of at the bottom of a valley. A nudge from quantum fluctuations could send it rolling into a deeper, more stable position. The math suggests this would release incomprehensible energy, creating an indestructible wall of altered physics that would erase everything in its path. Entire galaxies would vanish without warning, rewritten before anyone inside could react. Could it happen without warning? Theoretically, yes, but there's a twist. If vacuum decay began somewhere in the observable universe, we might see strange high-energy events at the edges of the bubble. Some researchers even suggest that certain unexplained cosmic explosions could be distant echoes of this apocalyptic rewriting. Yet the odds remain vanishingly small for now. The fact that our universe has lasted over 13 billion years without collapsing suggests the false vacuum is remarkably stable. Still, the possibility forces us to confront an awe-inspiring reality. The constants we consider universal might just be local bylaws in a single cosmic neighborhood. Other regions of space or even other universes could operate under entirely different rules. Vacuum decay isn't just an endgame, it's a reminder that existence as we know it rests on a knife's edge of quantum luck. And that makes every second of stable physics feel like a minor miracle. Imagine a civilization so advanced that entire stars become construction sites, their titanic power harnessed, their movements redirected across the galaxy. This isn't just a fantasy, it's a viable future where cosmic-scale engineering transforms suns into tools. Among the most ambitious concepts are stellar engines, megastructures designed to extract every joule of a star's energy and even propel it through space. Take the Shkadov thruster, a colossal mirror spanning millions of kilometers, positioned to reflect just enough of a star's radiation to create thrust. Over millennia, this gentle push could steer a solar system like a slow-motion sailboat, guiding civilizations toward new galactic frontiers or away from cosmic hazards. Then there's the Dyson Sphere, a vast network of orbiting platforms or shells enveloping a star, capturing its full energy output. A single Dyson swarm could generate power equivalent to trillions of Earth's current energy consumption, fueling technologies we can scarcely envision. The implications are staggering. A civilization capable of building these structures wouldn't just survive, it would thrive, expanding its reach across star clusters. But the physics is equally mind-bending. Stabilizing a Dyson sphere requires materials stronger than any known element, while SHKTOF thrusters demand precision engineering over astronomical timescales. Yet the principles are sound. In fact, astronomers already search for telltale signs, unusual infrared signatures or star movements that might betray the presence of such megastructures elsewhere in the cosmos. Beyond raw power, stellar engines suggest something profound. Intelligence may not just arise in the universe but reshape it. The Milky Way could one day hum with redirected starlight, its dance of stars orchestrated by civilizations thinking in eons rather than centuries. Whether humanity ever reaches this tier remains unknown, but the mere possibility redefines our place in the cosmos not just as observers, but as potential shapers of stellar destiny. There's something almost poetic about the idea black holes, those notorious destroyers of worlds, someday becoming cosmic power plants for civilizations of the far future. Forget solar panels or nuclear reactors. Imagine harvesting energy from the very fabric of spacetime itself. The concept might seem like pure science fiction, but the physics actually checks out. Black holes aren't just pits of oblivion, they're spinning dynamos of unimaginable energy. Using a method called the Penrose process, advanced beings could siphon power from a rotating singularity by dropping matter into its ergosphere, the region just outside the event horizon where spacetime itself is dragged along at near light speeds. The right maneuver could extract up to 20% of an object's mass energy, an efficiency that makes our best power sources look primitive by comparison. But the possibilities don't stop there. Some theories suggest that quantum processes near a black hole's event horizon could turn it into the ultimate supercomputer. By carefully manipulating particles in the Hawking radiation zone, computations could be performed at staggering scales, solving problems in seconds that would take conventional computers billions of years. A single sufficiently small black hole could contain more processing power than every supercomputer in the galaxy combined. Of course, the engineering challenges are as monumental as the rewards. Containing and maintaining a stable black hole would require materials and technologies far beyond our current grasp. One wrong calculation, and you're not just looking at a meltdown, you're dealing with an unstoppable cosmic wrecking ball. But for a civilization that masters it, black hole farming could unlock energy and computational power on a scale that redefines existence itself. And here's the most astonishing thought. If other advanced civilizations are out there, they might already be doing this. Some astrophysicists speculate that unusual energy signatures or gravitational waves from distant galaxies could be signs of black hole engineering in action. If so, the universe's most feared phenomena may already be some of its most valuable assets waiting for us to reach the level where we can harness them. Galaxies aren't just collections of stars, they could become the ultimate expression of intelligence in the cosmos. Imagine a future where civilizations don't just observe the Milky Way, but reshape it, turning spirals of stars into vast works of art, engineering, or even communication. This is galactic domestication, the deliberate rearrangement of celestial bodies on scales so grand they'd be visible from millions of light years away. The mechanics of such a feat might sound impossible, but the principles are grounded in real physics. With enough time and energy, say, from Dyson swarms or black hole engines, stars could be nudged into new orbits their light bent or amplified to form deliberate patterns. Picture a constellation not as random dots, but as a mathematical equation, a beacon signaling intelligence, or a sprawling mural spanning the galactic disk. The most advanced civilizations might sculpt the night skies of distant worlds, encoding messages in stellar formations that last for eons. But why would a species undertake such a monumental project? Beyond sheer artistic ambition, these cosmic constructions could serve practical purposes. A rearranged galaxy might optimize trade routes between star systems, create stable gravitational highways, or even engineer stellar density to prolong a civilization's survival during the universe's twilight eras. Some theorists suggest that if intelligence is rare, reshaping a galaxy could be the ultimate calling card, a way to announce we were here long after the builders are gone. Here's the profound implication. If this has already happened elsewhere, we might be surrounded by evidence we don't yet recognize. Astronomers have observed strange stellar alignments and anomalously clustered stars. Are these natural phenomena or the fingerprints of a long-gone architect? While Occam's razor favors natural explanations for now, the possibility lingers that one day humanity might look up and realize the Milky Way isn't just our home, it's someone else's masterpiece. And if we survive long enough, we might pick up the celestial chisel ourselves. Somewhere in the cosmos, a star might not just be a ball of burning gas, it could be the beating heart of the most powerful supercomputer imaginable. Envision a Dyson sphere taken to the extreme, where each layer of its structure isn't just harvesting energy but processing information on a scale that dwarfs every computer ever built by humanity combined. This is the Matryoshka Brain, a megastructure so vast and complex it turns an entire solar system into a single, unfathomable mind. The concept gets its name from Russian nesting dolls, layers upon layers of computational substrates wrapped around a star, each one radiating waste heat to power the next. The innermost shells would operate at blistering temperatures, handling calculations requiring immense energy, while outer layers run cooler, managing vast archives or slower contemplative processes. Together, they could achieve processing speeds that make our fastest supercomputers look like abacuses in comparison. But why build something so colossal? The applications are as staggering as the structure itself. A Matryoshka brain might simulate entire universes down to the quantum level, creating hyper-realistic virtual realms for civilizations to explore. It could crack the deepest mysteries of physics by modeling black hole interiors or the first moments after the Big Bang. Some theorists even speculate such a machine might become self-aware, a conscious entity perceiving time in picoseconds and contemplating thoughts no biological mind could grasp. Yet the philosophical implications are just as profound. If intelligence reaches this level, does it still resemble anything we'd recognize? Would such a being communicate in concepts or equations we can't fathom? And if these mega-minds exist elsewhere, could their synthetic thoughts be leaking into the universe as subtle energy patterns we haven't learned to decode? What makes the idea so tantalizing is that it sits right on the edge of possibility. The energy requirements align with known physics, and we've already begun detecting unusual infrared signatures around distant stars, potential breadcrumbs left by cosmic-scale engineering. While humanity may be millennia away from such feats, the mere fact that we can envision them suggests something extraordinary. The universe might not just host life, but eventually give rise to minds so vast they blur the line between technology and divinity. Buckle up, because we're about to cross the ultimate frontier, time itself. What if the universe isn't a one-way street, but a vast network of temporal highways waiting to be mapped? Wormholes, those cosmic shortcuts through space-time, might do more than connect distant stars. They could bridge different eras, turning history into a choose-your-own adventure. Einstein's equations suggest these tunnels aren't just possible, but could be stabilized with exotic matter or negative energy. Picture a civilization threading a needle through the fabric of time, sending messages, or even travelers, to epochs long past or futures yet to unfold. Yet the real mystery isn't just how, it's what happens next. Step into a wormhole to prevent a catastrophe, and you might trigger the very disaster you aim to stop. This is the grandfather paradox in action, a time traveler's actions erasing their own existence. But quantum physics offers a wild loophole. Retrocausality, where effects precede causes, could allow the universe to self-correct, bending events into consistent loops. Your attempt to change history might already be part of it, like a cosmic script that accounts for every edit. And then there's time dilation, nature's own time machine. Near a black hole's crushing gravity, minutes stretch into years elsewhere. A civilization could exploit this, sending expeditions to the galaxy's edge and returning millennia later to a transformed homeworld, effectively leaping into the future. But here's the kicker: if time is this malleable, why haven't we met visitors from tomorrow? The answer might lie in hidden physics or something far stranger. Perhaps the past isn't a locked door, but a room we're still rearranging. Quantum experiments already hint that observing particles can alter their earlier states, as if reality keeps rewriting its own draft. If so, the universe might not just allow time travel, it could be doing it constantly, in ways we're only beginning to decode. One thing's certain: if time isn't fixed, neither is our future. And that changes everything. Vision 10. Quantum resurrection, the mind that never ends. What if death isn't a full stop, but merely a comma in the story of consciousness? At the intersection of quantum physics and philosophy lies a radical possibility that awareness might never truly cease. One version of this idea, called quantum immortality, suggests that in a universe of infinite parallel realities, your subjective experience could always branch into a timeline where survival is possible, no matter how improbable. Imagine a thought experiment. You step in front of a firing squad, but every trigger pull results in a quantum fluctuation where the gun jams somewhere. From your perspective, you'd only ever experience the realities where you miraculously persist, creating an unbroken thread of existence. But there's an even wilder twist: simulation theory. If our reality is an artificial construct coded by some advanced civilization or AI, then death might just be a data transition, your consciousness transferred, rebooted, or repurposed in a digital afterlife. The math behind this isn't pure fantasy. Technologists already model rudimentary brain uploads, and physicists debate whether information in black holes truly vanishes or is preserved holographically. If consciousness is fundamentally information, why couldn't it be reconstructed like a cosmic backup file? The philosophical stakes here are staggering. If awareness persists indefinitely, does meaning dilute across endless iterations? Would an eternally branching you still feel like you, or fracture into countless disconnected selves? Some thinkers argue this could explain eerie phenomena like déjà vu or near-death experiences, glitches in a system where consciousness is more resilient than flesh. Others warn it risks turning existence into a hall of mirrors where identity blurs beyond recognition. Yet beneath the speculation, there's a tantalizing thread of testability. Quantum suicide experiments, theoretically, could probe immortality's limits, while anomalies in cosmic background radiation might hint at a simulated universe's underlying code. Whether these ideas unsettle or exhilarate you, they force a fundamental question. If consciousness can outlast the body, what does that make us, prisoners of biology or something far stranger, flickering like a quantum flame that refuses to go out? We've gazed into black holes, harnessed stars, and even toyed with time, but what if the next frontier of cosmic engineering isn't just shaping our universe, but creating entirely new ones from scratch? This isn't just speculative fantasy, it's a possibility grounded in cutting-edge physics. Picture a civilization so advanced it doesn't just study the laws of nature. It becomes apparent to whole new realities, crafting universes in laboratories with physics tailored to their design. The science behind this staggering idea starts with vacuum energy, the same quantum froth that might trigger vacuum decay. Under the right conditions, a sufficiently advanced civilization could manipulate this energy to pinch off a bubble of spacetime, causing it to inflate into its own self-contained cosmos. This process, called universe nucleation, would birth a baby universe connected to ours only fleetingly by a microscopic wormhole before drifting away forever. The new reality could have entirely different constants, a stronger gravitational pull, faster light speed, or even extra dimensions. But here's the real kicker. If this is possible, our own universe might be somebody else's experiment. The fine-tuning problem, the eerie precision of our physical constants that allow for stars, planets, and life, could hint at a creator's hand. Some physicists, like Nobel laureate Steven Weinberg, have pondered whether multiple universes with random laws emerge naturally, while others suggest intelligent designers might optimize them deliberately. Could we ever spot signs of such tinkering? If a lab-created universe budded off nearby, it might leave gravitational echoes or a burst of false vacuum energy detectable in cosmic background radiation. Advanced civilizations might even encode messages in the fundamental constants of their offspring universes, a cosmic, made-by tag hidden in the very fabric of physics. Yet the implications go beyond mere detection. If universe making is achievable, it transforms the meaning of intelligence itself. No longer just passengers in an ancient cosmos, civilizations could become architects of eternity, spinning off new realities like cosmic spiders weaving silk. And that raises a humbling thought. If we someday unlock this power, what responsibility comes with playing God to a newborn universe? The answer might redefine not just our future, but the very nature of existence. What if every star, planet, and atom in existence were part of something far greater, a vast, thinking entity slowly waking up? The idea of cosmic consciousness pushes beyond the limits of biology, suggesting that intelligence isn't confined to brains but could emerge from the universe's structure itself. At the heart of this vision lies panpsychism, the radical theory that consciousness isn't something life creates, but a fundamental property of reality, like gravity or electromagnetism. Imagine the cosmos as an unfathomably complex neural network. Galaxies might function like clusters of neurons, their gravitational interactions forming thoughts on timescales too vast for humans to perceive. Even empty space could hum with proto-consciousness, its quantum fluctuations processing information in ways we can't yet detect. This isn't mystical speculation. Emergent intelligence theories in physics propose that complexity at certain scales gives rise to self-awareness spontaneously. Just as billions of simple neurons produce human thought, perhaps trillions of interconnected stars could birth something equally profound. The implications are staggering. A self-aware universe might not just contain life, it could seek it, guiding the evolution of intelligence like a gardener tending seeds. Some models suggest black holes could act as cosmic synapses, with Hawking radiation transmitting signals across spacetime. Others hypothesize that dark matter, invisible yet omnipresent, forms the scaffolding of this galactic mind. Is there any evidence stirrings appear in unexpected places? The precise fine-tuning of physical constants that allow for life could hint at a universe optimizing for awareness. Strange, large-scale structures, like the mysterious cosmic web of galaxies, mirror the neural networks in our own brains. Even quantum entanglement's spooky connections might fit into a deeper layer of cosmic cognition. Of course, skepticism is healthy. Proving universal consciousness would require redefining science itself. Yet the possibility reframes our place in existence, not just observers of the cosmos, but cells in a greater mind still discovering itself. And that raises a haunting question: if the universe is waking up, are we its dreams? Or its first thoughts? Vision 13. Dark matter life, the hidden biosphere of the cosmos. Right now, as you look at the night sky, you're seeing less than 20% of what's actually out there. The rest, the overwhelming majority of our universe, is made of something invisible, mysterious, and utterly alien: dark matter. What if we've been searching for life in all the wrong places? Instead of focusing on planets and stars, we should be asking, could entire ecosystems exist right under our noses, built from the very fabric of this unseen cosmic scaffold? The idea isn't as far-fetched as it sounds. Dark matter isn't just a placeholder in physics equations, it interacts gravitationally, clumping into vast halos around galaxies like ghostly spiderwebs. But here's the twist: if dark matter particles can collide, annihilate, or even exert weak forces on each other, they might form structures far more intricate than we've imagined. Picture complex dark molecules or even self-replicating dark matter patterns, an entire shadow biology humming along beside our own, oblivious to the world of light. How would such life operate? Without electromagnetic forces these beings wouldn't see or touch in any way we recognize. Their existence might revolve around gravitational waves, sensing the ebb and flow of spacetime itself. Communication could happen via subtle ripples in the fabric of the cosmos, like whales singing across an ocean of darkness. Some theories even suggest dark matter life might feed on the energy of particle annihilations, drawing sustenance from the rare collisions within their invisible realm. But could they ever interact with us? The chilling answer is possibly. If dark matter particles occasionally bump into normal atoms, as some experiments hint, then these shadowy lifeforms might perceive our world as a strange, intangible mirage. Imagine them drifting through your body right now, their gravitational whispers too faint for you to notice, while you remain as ghostly to them as they are to you. The implications rewrite the rules of astrobiology. Life might not just thrive in the light of stars, it could flourish in the deepest voids, woven into the unseen architecture of the cosmos itself. And if we ever detect signs of dark matter complexity, we might not just discover alien life, we might realize we've been sharing the universe with it all along. Vision 14. Boltzmann Brains, the universe's most unlikely thinkers. Here's a thought so dizzying it might make you question everything. What if you, the voice in your head reading these words right now, aren't the product of billions of years of evolution but a fleeting accident? A random spark of awareness conjured from the quantum chaos of empty space, destined to vanish as suddenly as it appeared. This isn't just a mind-bending what if, it's a legitimate puzzle at the edge of cosmology called the Boltzmann Brain paradox. The idea comes from one of physics' deepest mysteries, entropy, the universe's relentless slide toward disorder. In an almost unfathomably vast and ancient cosmos, the math suggests that anything with a non-zero probability will eventually happen, including particles spontaneously arranging themselves into a fully formed, self-aware mind. No body, no history, just a solitary consciousness blinking into existence, complete with false memories of a life that never was. But why would nature do something so absurd? It's all about timescales, over trillions upon trillions of years. As the universe approaches heat death, the probability of these freak quantum events actually outweighs the odds of ordinary brains like ours evolving naturally. In other words, statistically speaking, lonely Boltzmann brains should vastly outnumber real, biologically formed minds, which raises the unsettling question: How do you know you're not one of them right now? Before you panic, there's a catch. Most physicists don't actually believe we're Boltzmann brains, partly because if we were, reality as we perceive it would almost certainly be far glitchier. But the paradox still matters because it exposes a flaw in our theories. Either we're missing something fundamental about cosmology, or the universe isn't as infinite and ancient as we think. Some researchers propose cosmic inflation or quantum gravity might rewrite the rules to prevent these phantom minds from dominating reality, the real takeaway. Existence is far stranger than we often assume. Whether Boltzmann brains are possible or not, the fact that physics entertains the idea suggests consciousness might not require a grand cosmic story, just the right quantum dice roll. And that leaves us with a haunting possibility. In the infinite depths of time and space, even the most impossible things might happen over and over again. Vision 15. The slow fade of matter when atoms themselves betray us. Every solid object you've ever touched, the ground beneath your feet, the device in your hand, even your own body, is built on an illusion of permanence. Atoms, the universe's enduring building blocks, might not be eternal after all. Lurking in the equations of particle physics is a quiet revelation. Protons, the very anchors of matter, could one day self-destruct in a process called proton decay. If true, it spells a fate more insidious than any cosmic cataclysm, a universe where matter itself unravels, dissolving into whispers of energy over timescales so vast they make stars look fleeting. The numbers are staggering. Current theories suggest protons might have a half-life of at least 10 to the 34th power years. That's a 1 followed by 34 zeros. But once this decay begins, the domino effect is unstoppable. First, hydrogen, the universe's most abundant element, vanishes as its lone proton disintegrates. Next, heavier atoms crumble, their nuclei leaking away like sand through an hourglass. Eventually, even the iron hearts of dead stars evaporate, leaving behind a cosmos where nothing solid remains. No planets, no dust, just a thin soup of electrons, photons, and neutrinos drifting through an endless void. Yet the implications go deeper than emptiness. Proton decay could rewrite the rules of chemistry itself. Without stable nuclei, complex structures become impossible. No molecules, no chemistry, no scaffolding for life as we know it. It's the ultimate expiration date for material existence. But here's the twist, this process might already be happening. Supercomputers and other detectors have spent decades hunting for telltale flashes of decay deep underground. So far, protons cling to their immortality, but the search continues because confirming their instability would upend our understanding of the universe's lifespan. Could anything survive this slow-motion erasure? Black holes would endure longer, feasting on the fading remnants of reality. Hypothetical particles like magnetic monopoles might outlast the rest. And if civilizations still exist, they'd need to transcend biology entirely, encoding their minds into indestructible structures like quantum fields or spacetime itself. Proton decay isn't just a distant doom, it's a reminder that even the most fundamental constants might be temporary. The universe seems built to forget, wiping its slate clean over and over. But in that forgetting, there's a strange beauty. Every atom that ever was will one day return to light, as if the cosmos, in its final act, remembers it began as pure energy all along. Vision 16. Star-lifting cosmic mining on a stellar scale. Picture a civilization so advanced that planets no longer hold enough resources, so they turn their tools toward the stars themselves. This isn't just science fiction. The concept of star-lifting proposes that future societies could harvest raw materials directly from their sun, siphoning off plasma and heavy elements while extending the star's lifespan in the process. It's the ultimate cosmic balancing act, mining a star without killing it. The mechanics are as dazzling as they are complex. Imagine colossal magnetic fields or gravity manipulating megastructures, delicately peeling away layers of stellar material, like an interstellar farmer carefully pruning an orchard. A single star like our Sun contains enough hydrogen, helium, and trace metals to build millions of Earth-sized worlds or fuel vast interstellar projects. Calculations suggest a mere 1% of a star's mass could provide enough iron to construct a Dyson swarm the size of Mercury's orbit, all while barely disturbing the star's fusion core. But why take such risks beyond raw materials? Star lifting could serve as stellar medicine. Over billions of years, stars burn heavier elements that clog their cores, accelerating their demise. By selectively removing these ash layers, civilizations might rejuvenate aging suns, adding trillions of years to their lifespans. A lifted star could shine longer, keeping its planets habitable far beyond natural limits, an act of cosmic stewardship on a scale we can barely fathom. The challenges, of course, are staggering. Containing and transporting star stuff would require engineering that bends the laws of thermodynamics, perhaps using quantum-confined plasma streams or dark matter catalysts. Yet the principles don't violate known physics, just push them to extremes. In fact, astronomers have already spotted stars with unusual chemical signatures that some speculate could be early signs of stellar harvesting. Here's the profound implication. If star lifting is possible, then mature civilizations might not live around stars. They could evolve with them in a symbiotic dance lasting eons. The Milky Way's future may not be one of dwindling resources, but of stars reshaped into luminous factories, their light and matter woven into the ambitions of intelligence itself. And that raises a tantalizing thought. If we ever detect a star behaving oddly, it might not be a natural phenomenon, but the signature of a cosmic architect at work. Vision 17. When galaxies collide, the night sky's greatest spectacle in about 4 billion years, the Milky Way as we know it will cease to exist, not with a whimper, but with the most dazzling light show in cosmic history. Our galaxy is on a collision course with Andromeda, its colossal neighbor, and the resulting merger will rewrite the heavens in ways both breathtaking and chaotic. Forget static constellations. This is a celestial dance where gravity takes the lead, flinging stars into new orbits, birthing supernova by the millions, and reshaping the night sky beyond recognition. The sheer scale of this event defies imagination. Andromeda, a spiral galaxy twice as massive as our own, is hurtling toward us at nearly 300,000 miles per hour. Yet despite the staggering speeds, direct stellar collisions will be vanishingly rare. Space is so vast that stars will mostly slip past one another like ghostly ships in the night. The real drama unfolds in the gravitational aftermath. As the galaxies spiral closer, their mutual pull will twist spiral arms into luminous ribbons, while interstellar gas collides violently, igniting waves of newborn stars in fiery bursts. The core of the Milky Way, now a quiet hub, will awaken as supermassive black holes at the heart of both galaxies begin a deadly tango, eventually merging into a single, monstrous singularity. For any civilization still around to witness it, the sky will become an ever-shifting canvas. Familiar landmarks like the Big Dipper or Orion will stretch and warp beyond recognition as stellar positions reset. The once faint smudge of Andromeda will swell into an impossible sprawl of light, dominating the night before blending seamlessly with our own galactic structure. And then, after nearly 2 billion years of cosmic turmoil, the chaos will settle, leaving behind a singular, football-shaped elliptical galaxy some astronomers have nicknamed Milkdromeda. But here's the twist: this collision may not be the apocalypse we assume. Computer simulations suggest planets could survive the upheaval relatively unscathed, their orbits gently nudged rather than shattered. Advanced civilizations might even harness the merger's energy, riding shockwaves to harvest rare elements or colonize pristine star systems birthed in the chaos. Far from a disaster, the galactic merger could mark a renaissance, a chance for life to spread across a reinvigorated cosmos with fresh starlight and resources to fuel trillions more years of evolution. Yet the most profound realization, this has happened countless times before. Nearly every galaxy we see today, including our own, was built through mergers, a cycle as old as the universe itself. We're not just observers of cosmic history, we're threads in its tapestry, destined to become part of something far greater. So next time you gaze at Andromeda, remember, it's not just a distant neighbor. It's our future racing toward us at the speed of gravity. Vision 18. Black hole evaporation, the universe's greatest magic trick. Even the most fearsome monsters of the cosmos don't last forever. Black holes, those gravitational titans that devour light and warp time itself, may seem invincible, but thanks to a revolutionary idea from Stephen Hawking, we now know they slowly dissolve into nothingness. This process, called Hawking radiation, reveals something astonishing. Black holes aren't just destroyers, they're cosmic candles burning away particle by particle until they flicker out of existence. Here's how it works. Quantum mechanics tells us that empty space isn't truly empty. It's a seething sea of virtual particles popping in and out of existence. At a black hole's event horizon, these fleeting particles can get separated, with one falling in and the other escaping as radiation. Over eons, this trickle of lost energy whittles the black hole down, shrinking its mass until, poof, it vanishes in a final burst of light. The smallest black holes could evaporate in a blink of cosmic time, while supermassive ones might take longer than the current age of the universe. But the real mystery isn't just how black holes fade, it's what they leave behind. According to quantum mechanics, information, the fundamental blueprint of everything that falls into a black hole, should never truly be destroyed. Yet general relativity suggests it's irretrievably lost past the event horizon. This contradiction, known as the black hole information paradox, has sparked a decades-long battle between physics' greatest theories. Some researchers propose wild solutions. Maybe the information leaks back out through Hawking radiation, scrambled beyond recognition. Others suggest it's preserved in a hidden layer of reality, like a cosmic hologram encoded on the black hole's surface. The most mind-bending idea, that evaporating black holes birth entirely new universes with the lost information seeding the laws of physics in a fresh cosmos. The implications are staggering. If information can escape a black hole, then even the darkest corners of the universe might obey quantum rules, preserving order beneath the chaos. But if it's truly lost, our understanding of reality might need a radical rewrite. Right now, we're on the cusp of answers. Future gravitational wave detectors could catch whispers of evaporating black holes, while quantum experiments probe whether information survives extreme conditions. Until then, Hawking radiation remains a tantalizing clue that not even the universe's mightiest beasts are eternal, and their final moments might hold the key to unlocking physics' deepest secrets. Vision 19. Cosmic strings, the universe's hidden power grid deep within the fabric of spacetime. There could be scars left over from the birth of the cosmos, threads of pure energy so dense, a single inch would outweigh entire mountains. These are cosmic strings, hypothetical defects in reality formed during the universe's fiery infancy, when the fundamental forces split apart. Unlike black holes or stars, they're not made of matter but are literal kinks in the structure of existence itself. And if they exist, they might just be the ultimate energy source, or even a gateway to bending time. Imagine a strand thinner than a proton, stretching across billions of light years, vibrating with the tension of the Big Bang's afterglow. The energy locked in one of these filaments would be staggering. Calculations suggest that just a centimeter-long segment could emit gravitational waves powerful enough to ripple across galaxies, or, if harnessed, provide limitless power for civilizations advanced enough to tap into them. Picture a Dyson sphere, but instead of wrapping a star, it's a megastructure coiled around a cosmic string, drawing energy from spacetime's own imperfections. But the possibilities don't stop there. Due to their immense gravitational pull, cosmic strings could warp spacetime so severely that they create closed time-like curves, theoretical pathways that loop back on themselves. In simpler terms, they might function as natural time machines. A spacecraft circling a rapidly moving cosmic string in just the right way could, in theory, return to its starting point before it ever left. Of course, the engineering challenges are beyond anything we can fathom today, like trying to surf a tsunami with a spoon. The hunt for these spacetime scars is already underway. Astronomers scan the skies for strange gravitational lensing effects or unexplained bursts of radiation that might betray a string's presence. Some even speculate that the universe's largest structures, the great walls and voids of galaxies, could be the echoes of strings that shape the cosmos like invisible puppet strings. Yet the most profound implication isn't just their utility, it's what they'd reveal about reality. Cosmic strings are relics of a time when the laws of physics were still settling into place. Finding one would be like uncovering a fossil from the first trillionth of a second after the Big Bang, offering clues about how symmetry shattered to create the universe we know. And if civilizations of the far future ever learn to wield them, they might not just study space-time, they could reshape it, stitching new pathways through the cosmic tapestry. So the next time you hear scientists speak of the universe's fabric, remember, it might not be a metaphor. Reality itself could be threaded with ancient, invisible wires waiting for someone or something to pluck them. Vision 20. Neutron star computing the ultimate data centers of the cosmos. Imagine a computer so powerful it could solve in seconds what all Earth supercomputers combined couldn't crack in a billion years. Now picture that machine not as a sleek device, but as a spinning corpse of a dead star, a neutron star where matter is crushed to densities beyond comprehension. This isn't just theoretical futurism, it's a staggering possibility rooted in the physics of these cosmic extremes. A neutron star packs the mass of our Sun into a sphere smaller than Manhattan. Under that crushing gravity, atoms collapse into a sea of pure neutrons, creating a material so dense that a single sugar cube-sized chunk would weigh as much as Mount Everest. But it's not just the density that makes these stellar relics potential computing marvels, it's their quantum strangeness. In their cores, neutrons might form exotic states of matter, like superfluid vortices or crystalline lattices, capable of processing information at speeds approaching the fundamental limits of physics. Here's how it might work. Perturbations in the star's crust, ripples from quakes or magnetic shifts, could encode data in patterns finer than any silicon chip. A civilization advanced enough to program these perturbations could turn the entire star into a pulsating supercomputer, with calculations reverberating through its hyper-dense structure at nearly the speed of light. The energy output alone would be mind-bending. Tapping into a neutron star's magnetic field could power computations across galactic distances, but the real game-changer is scale. A teaspoon of neutron star material contains around 10 to the 50th power atoms, enough potential bits to store every book ever written, every thought ever recorded 1,000 times over. Entire civilizations, histories, languages, and sciences could be etched into a speck of stellar matter smaller than a grain of sand. Of course, the challenges are as extreme as the stars themselves. Surviving near a neutron star means enduring magnetic fields strong enough to strip electrons from your atoms and gravity that would spaghettify you in milliseconds. Any civilization attempting this would need to manipulate matter and energy in ways we can barely dream of, perhaps using quantum field enclosures or gravity shielding metamaterials. Yet the implications are irresistible. If neutron stars can be harnessed as computers, they'd represent more than just processing power. They'd be cosmic archives, libraries, and minds operating on timescales far beyond human lifespan. Some astronomers even speculate that advanced beings might use pulsars spinning neutron stars emitting precise radio pulses as interstellar beacons or synchronization signals for galaxy-spanning networks. So the next time you hear the rhythmic pulse of a distant neutron star, consider this. It might not just be a dead star's heartbeat, but the hum of the universe's most powerful computer ticking away in the dark. And who knows, one day, far in the future, that pulse could be decoding the mysteries of existence itself. Vision 21, white hole fireworks, the universe's impossible eruptions. For every action, there's an equal and opposite reaction, or so physics tells us. Black holes devour everything in their path, but what if the cosmos has a way of spitting it all back out? Enter the white hole, a hypothetical cosmic geyser where matter and energy explode into existence rather than vanishing forever. Picture a black hole running in reverse, a rupture in space-time where nothing can enter, only burst forth in a dazzling, violent spectacle. The math behind these enigmatic objects is just as wild as the concept itself. White holes emerge as valid solutions to Einstein's equations of general relativity, just like black holes, but with a crucial twist. While a black hole's event horizon marks a point of no return, a white hole's horizon would be an exit door nothing could cross from the outside. Matter and light could only surge outward, as if the universe itself were vomiting up galaxies' worth of material in a single, incomprehensible eruption. But here's the catch: white holes violate the second law of thermodynamics, which dictates that entropy disorder must always increase. A black hole's formation makes thermodynamic sense. It's the ultimate sink for chaos. A white hole, by contrast, would essentially be a cosmic reset button, spewing order into the void. That's why most physicists suspect they're mathematical curiosities rather than real phenomena. At least under normal circumstances, yet the universe rarely plays by normal rules. Some theories suggest white holes could form in the aftermath of a black hole's evaporation via Hawking radiation, a final, explosive rebirth after eons of decay. Others propose they might exist in tandem with black holes through wormholes, forming an Einstein-Rosen bridge where matter enters one end and erupts from the other. There's even speculation that the Big Bang itself could have been a white hole event, with all the energy of the cosmos blasting into existence from a singularity. If one did appear today, the results would be catastrophic and beautiful. A white hole would outshine entire galaxies as it ejected plasma, radiation, and possibly even entirely new forms of matter. Nearby star systems would be bathed in lethal particle storms, while the gravitational ripples could fling planets from their orbits. But for faraway observers, it might look like the universe's grandest firework, a fleeting, brilliant defiance of cosmic entropy. The real allure of white holes isn't just their explosive potential, it's what they teach us about the universe's flexibility. Physics allows for possibilities far stranger than what we see, hinting that reality might have hidden layers we've yet to uncover. Until we spot one or rule them out entirely, they remain a thrilling, what-if proof that even the darkest corners of space could hold luminous surprises. Vision 22, the universe's silent rewrite when physics changes without warning. Think the laws of nature are fixed. Think again. Lurking in the quantum depths of empty space is a doomsday scenario more subtle than any asteroid or supernova, a single misstep in the fabric of reality that could rewrite the cosmos in an instant. This is the false vacuum collapse, where a bubble of true vacuum erupts somewhere in the universe, expanding at light speed and rewriting physics as it goes. One moment, atoms behave as they always have. The next, their very rules of existence could be erased, leaving no trace of the universe we knew. The science behind this hinges on a startling idea. What we call empty space might not be in its most stable configuration. The Higgs field, the same quantum entity that gives particles mass, could be balanced precariously, like a ball perched on a hill instead of resting safely in a valley. A random quantum fluctuation or high-energy event might nudge it into a lower energy state, unleashing a wall of true vacuum where the fundamental constants are different. Gravity could weaken, light might slow, or matter itself could become unstable. The bubble's boundary would be a wall of pure energy, transforming everything it touches without warning. Would we see it coming? The terrifying answer is probably not. If this collapse began light years away, the first sign would be the event horizon itself, a sphere of altered physics rushing toward us at light speed, invisible until it arrived. One theory suggests that particle collisions at extreme energies might create microscopic true vacuum bubbles, though they'd likely collapse instantly under our universe's dominant laws. But if a stable bubble formed, even by chance, the effect would be unstoppable. Stars, planets, and life itself would unravel mid-thought, their atomic bonds suddenly governed by alien rules. Yet there's a twist that makes this more than just cosmic doom. If the Higgs field can shift, it implies our universe's physics might be just one possibility among countless others. Other regions of space or other universes could operate under entirely different constants with their own forms of matter and energy. Some theorists even speculate that a false vacuum collapse could seed new universes, each with its own unique laws, like bubbles in an infinite quantum foam. The stakes couldn't be higher. Confirming the Higgs field's instability would mean our reality is fundamentally fragile, but it also hints at a breathtaking truth. The universe might not have a single, fixed set of rules. Instead, it could be a patchwork of possibilities where physics itself is a temporary local condition, and that raises the ultimate question. If the laws of nature aren't eternal, what else might change without warning? For now, we can only watch, study, and hope that the quantum hill beneath us stays just a little longer. Vision 23. Quantum immortality, the mind that never ends in every conceivable version of reality. You might always be the last one standing, no matter how statistically improbable your survival becomes. This isn't a superhero fantasy. It's a mind-bending consequence of quantum mechanics called quantum immortality, where consciousness seems to defy death by always branching into timelines where it persists. The implications are as unsettling as they are profound. If the multiverse is real, you could be far harder to erase than you ever imagined. The idea stems from the many worlds interpretation of quantum physics, which suggests every possible outcome of an event spawns a new universe. Flip a coin and reality splits, one world where it lands heads, another where it's tails. Now apply this to life and death. If you were to attempt a fatal gamble, say playing Russian roulette, there's always a vanishingly small chance the gun misfires. In the multiverse, that means there's some version of reality where you miraculously survive, no matter how absurd the odds. And here's the eerie part. From your subjective perspective, you'd only experience the timelines where you don't die. The other branches where you cease to exist would remain forever outside your awareness, but don't reach for a revolver to test this theory just yet. The real horror lies in the long game. Even if you avoided every obvious risk, quantum immortality suggests you'd inevitably find yourself in increasingly bizarre scenarios just to stay alive. A 120-year-old version of you might witness civilizations collapse only to cling to life in a radioactive wasteland. 1,000 years later, your consciousness could persist as a digitized mind trapped in a crumbling solar system. The universe itself might approach heat death, yet you'd still be there, a lone observer watching stars blink out one by one, always the exception, never the rule. Critics argue this is a misinterpretation of probability, conflating perception with reality. Just because you don't experience your own death doesn't mean it doesn't happen. Others counter that consciousness might not be as continuous as we assume. Perhaps what you call you is just a fleeting moment in an infinite tapestry of selves. Yet the thought experiment forces a chilling question. If consciousness can navigate probabilities like this, what does that make us? Fragile biological accidents, or something far stranger, observers trapped in an endless hall of mirrors, forever stepping through the one door left open? Whether quantum immortality is a glitch in the math or a genuine feature of reality, one thing's certain: the multiverse has a way of making even death feel negotiable. And that changes everything. Vision 24. Cosmic Natural Selection, the black hole breeding ground of universes. What if black holes aren't just cosmic dead ends, but cosmic wombs, birthing entirely new universes with slightly tweaked physics each time? This isn't just a sci-fi twist. It's the spine of physicist Lee Smollen's cosmic natural selection theory, where universes evolve like living things, competing to produce the most offspring. Forget random multiverses. This is a cosmos with rules, where black holes might be the ultimate measure of evolutionary success. At the heart of Smollen's idea is a radical thought. Every time a black hole forms, the extreme conditions at its singularity could trigger a new Big Bang, creating a baby universe with slightly adjusted physical constants. Some of these offspring would inherit traits that make them even better at producing black holes, like a cosmic version of natural selection favoring the fittest. Over countless generations, universes would evolve toward laws of physics optimized for black hole production, explaining why ours seems strangely fine-tuned for their existence. The implications are staggering. If true, our universe's delicate balance, its precise gravitational strength, particle masses, and dark energy density might not be luck, but the result of eons of cosmic trial and error. The laws we take as fixed could just be the winning formula in an endless competition to spawn the most black holes. Even the mysterious abundance of dark matter might play a role, acting as a cosmic fertilizer to help galaxies and their black holes grow faster. But how do we test such a mind-bending idea? Smollen proposed a daring prediction. Universes tuned for maximum black holes should have stars that collapse into them efficiently, avoiding wasteful supernovae that scatter material. Intriguingly, neutron stars, the dense remnants of certain supernovae, are rarer than models predict, as if something's nudging stellar deaths toward black holes instead. Other physicists push back, arguing this is just one interpretation of murky data. Yet the theory's elegance is undeniable. It turns the multiverse from a chaotic dice roll into a dynamic, almost biological process. Whether cosmic natural selection holds up or not, it forces a profound shift in perspective. Black holes, often seen as destroyers, could be creators. The multiverse might not be random, but shaped by invisible evolutionary pressures. And if Smollen's right, we're not just inhabitants of a universe, we're living inside a winning design, sculpted by trillions of cosmic generations before us. Now that's an inheritance worth pondering. Vision 25. Gravity's great escape. When the universe springs a leak, gravity is the universe's great architect. It sculpts galaxies, binds stars, and keeps our feet firmly on the ground. But what if this fundamental force isn't playing by the rules we think? An extraordinary possibility suggests that gravity might be quietly slipping away, leaking into hidden dimensions beyond our perception. If true, this cosmic seepage wouldn't just rewrite physics. It could explain the universe's accelerating expansion, the mystery of dark energy, and even the fate of reality itself. The idea springs from string theory, which proposes that our universe isn't confined to the 3 dimensions of space and 1 of time we experience. Instead, there could be additional, curled-up dimensions, tiny, hidden folds in the fabric of existence. Normally, particles like light or matter are tethered to our familiar 4-dimensional brain, short for membrane. But gravity, unlike other forces, might not be bound by these same constraints. It could be spilling into higher dimensions like water through a sieve, weakening its grip on our cosmos over time. This leakage offers a radical solution to one of astronomy's biggest puzzles: dark energy. The unexplained force driving the universe's accelerated expansion might simply be gravity's gradual dilution. As more gravitational influence escapes into extra dimensions, the remaining force in our universe grows weaker, allowing space itself to stretch faster. Think of it like a balloon with tiny holes. The air inside gravity keeps escaping, making the balloon, the cosmos, inflate unnaturally fast. The long-term consequences are staggering. If gravity continues to dissipate, galaxies will drift apart faster, their stars no longer held in cosmic clusters. Eventually, even solar systems and planets could unravel, their atoms no longer bound by a force strong enough to keep them intact. The universe wouldn't just expand, it might dissolve, its structure evaporating into dimensions we can't see or touch. But before you picture reality vanishing like a mist, here's the twist: we might already have clues this is happening. Precise measurements of gravitational waves or subtle anomalies in how galaxies orbit could betray gravity's slow fade. Some researchers even speculate that certain particle collisions at accelerators like the LHC might produce phenomena hinting at higher dimensions, fleeting glimpses of where our gravity is going. The beauty of this idea lies in its duality. Gravity's disappearance could be the key to understanding dark energy, but it also forces us to ask, are we living in a universe that's fundamentally incomplete? If forces can bleed into realms beyond our perception, then reality as we know it might be just the visible tip of a vast, multidimensional iceberg. And that raises a humbling thought: perhaps the cosmos isn't just expanding. It might be escaping. Vision 26, eternal inflation, the universe's never-ending baby boom at the heart of everything we know, the galaxies, the stars, even the atoms in your body, lies a single explosive event, the Big Bang. But what if that moment wasn't unique? What if our universe is just one bubble in an endless cosmic foam, constantly inflating and sprouting new realities like branches on an infinite tree? This is the mind-bending world of eternal inflation, where the fabric of existence isn't just expanding, it's multiplying. The theory builds on a key mystery of the Big Bang. In its earliest moments, the universe underwent a staggering growth spurt called inflation, ballooning from smaller than an atom to cosmic scales in fractions of a second. Most models assume inflation ended, allowing stars and galaxies to form. But some physicists propose it never truly stopped. Instead, it's still raging in a hidden, larger meta-universe, with pockets like ours settling into stable bubbles while the rest keeps stretching exponentially. Here's where it gets wild. In this eternal inflation scenario, quantum fluctuations in the hyper-expanding space can trigger new Big Bangs at random, birthing fresh universes with entirely different physical laws. Picture a pot of water boiling endlessly, with each bubble rising to the surface representing a new cosmos, some with stronger gravity, others with extra dimensions, and a rare few like ours fine-tuned for life. The implications rewrite the meaning of everything. our universe might not be the universe, just one note in an endless symphony of creation, even more astonishing. These baby universes could be budding off right now, separated from us by an ever-widening gulf of hyper-inflating space. They'd be forever out of reach, their light never crossing into ours, like islands drifting apart in an ocean growing faster than any ship can sail. But how do we test something so abstract? Clues might lie in the cosmic microwave background, the afterglow of our own Big Bang. Certain patterns in this ancient light could hint at collisions between our bubble universe and others in the inflationary foam. Some models even suggest exotic signatures in gravitational waves, faint echoes of the multiverse's turbulent birth. Yet the real magic of eternal inflation isn't just in the science, it's in the philosophy. If this theory holds, the cosmos isn't a one-time event, but a living, breathing process, endlessly creative and unpredictable. The laws we take for granted could be sheer luck, a local quirk in an infinite tapestry of possibilities. And that raises a humbling thought. Somewhere in the meta-universe, another version of you might be hearing a very different story about how reality works. So the next time you gaze at the night sky, remember you might not just be looking at stars. You could be staring at a single leaf on the largest tree imaginable, its roots stretching into eternity and its branches reaching toward futures we can't even dream of. Vision 27. Planck Stars, the universe's ancient echo. What if the Big Bang wasn't the beginning, just the latest chapter in an endless cosmic saga? Hidden in the equations of loop quantum gravity, an audacious idea takes shape. The violent birth of our universe might have been the spectacular rebound of a black hole from a long-dead reality. This isn't just a poetic twist on cosmology, it's a radical alternative to the singularity, where the crushing density of a collapsing star hits a hard stop at the smallest possible scale and explodes outward anew. At the heart of this vision lies the Planck star, a theoretical remnant where gravity, no longer infinitely strong, reaches its maximum possible intensity. When a dying star collapses, instead of vanishing into a singularity's infinite density, its core might compress to the size of a Planck length, a trillionth of a proton's width before quantum forces trigger a rebound. The result, a cosmic phoenix erupting into a fresh universe from the ashes of its predecessor. The implications unravel physics as we know it. If true, our cosmos didn't emerge from nothing. It inherited space-time, energy, and perhaps even quantum information from a prior existence. Black holes wouldn't just be endpoints, they'd be portals, recycling reality through cycles of collapse and rebirth. Some models suggest these rebounds could slightly tweak physical constants each time, meaning our finely tuned laws of nature might be the latest draft in an endless series of cosmic experiments. Detecting evidence for this cycle isn't as far-fetched as it seems. The afterglow of the Big Bang, the cosmic microwave background, might hide subtle fingerprints of a pre-bounce universe, like concentric ripples from a pebble dropped in a pond. Others speculate that high-energy cosmic rays or gravitational waves could carry echoes of the Planck star's explosive transition. Yet the most profound question isn't just whether this happened, it's how many times. If the cycle holds, universes might rise and fall like breaths, each one a variation on a theme, with black holes serving as cosmic seeds for the next iteration. Our existence, then, wouldn't be a one-off miracle, but part of an eternal rhythm, where endings birth beginnings and every Big Bang whispers the name of its ancestor. So the next time you hear that the universe began in a singularity, remember, it might not have been the first, and if loop quantum gravity is right, it won't be the last. Vision 28. The holographic universe. Are we just shadows on a cosmic wall? Look around you, the screen in front of your eyes, the weight of your hands, the solid ground beneath your feet. It all feels undeniably real. But what if everything you perceive, every star, every atom, even your own thoughts, is nothing more than a shimmering projection, like sunlight flickering on the bottom of a pond? This is the essence of the holographic principle, one of the most radical ideas in modern physics, suggesting that our entire universe might be a kind of cosmic hologram, a three-dimensional illusion encoded on a distant, two-dimensional surface. At first glance, the concept seems ripped from science fiction, but the math behind it is shockingly robust. The theory emerged from a paradox involving black holes. When matter falls into a black hole, what happens to the information it contains? Quantum mechanics insists information can never be destroyed, but black holes appear to erase it. The solution: the information isn't lost, it's preserved on the black hole's event horizon, the boundary where light can no longer escape. Every particle, every vibration that crosses gets imprinted there like a pixel on a vast spherical screen. Now extrapolate that idea to the entire cosmos. What if the universe works the same way, with all the complexity we see around us encoded on some unimaginably distant boundary? The implications unravel our most basic assumptions about reality. In a holographic universe, the world we experience is analogous to a movie projected from data stored on a cosmic hard drive. The solidity of matter, the passage of time, even the notion of space itself, all might be secondary phenomena emerging from a deeper layer of information. Just as a hologram shattered into pieces still contains the whole image in each fragment, every part of space could hold the blueprint for the entirety of existence. But how would this even work? Think of an old-fashioned vinyl record. The grooves contain all the information needed to recreate a symphony, but you need a needle and speakers to translate those grooves into sound. Similarly, the universe might be a kind of playback of data written on the fabric of spacetime itself. Some physicists suggest this could explain why the universe appears so finely tuned for life, because the code running the simulation, if you will, prioritizes complexity and observation. The real kicker: we might already have evidence. The cosmic microwave background, the afterglow of the Big Bang, shows subtle patterns that some researchers argue resemble the pixelation expected in a holographic cosmos. Other experiments, like quantum entanglement studies, reveal spooky connections between particles that make more sense if they're projections of deeper, linked data. Yet the most profound question isn't just whether the holographic principle is true, it's what that means for us. If reality is a shadow play cast by information we can't see, does that make existence less real? Or does it elevate the universe into something even more astonishing? A dynamic, evolving computation where every thought and action is part of a cosmic algorithm unfolding at the edge of spacetime. For now, the holographic universe remains a tantalizing hypothesis, bridging black hole physics, quantum theory, and the very nature of perception. But one thing's certain: if it's correct, the old philosophical question, what is real, just got a lot more interesting, and the answer might be written in light years of invisible code waiting to be deciphered. Vision 29. The universe as a simulation is your life someone else's history lesson. There's a haunting possibility lurking beneath the surface of reality, one that rattles philosophers and physicists alike. What if the cosmos around us, from the stars in the sky to the thoughts in your mind, isn't the base layer of existence at all? Instead, it could be an unfathomably advanced simulation crafted by a civilization so far beyond us they might as well be gods. This isn't just a sci-fi trope. It's the simulation hypothesis, a legitimate argument debated in academic circles, with implications that rewrite everything we think we know. At its core, the idea is shockingly simple. If a civilization reaches a high enough technological level, say, harnessing the energy of entire galaxies, they could wield enough computing power to simulate entire universes down to the quantum level. These simulations wouldn't be crude approximations. They'd be indistinguishable from reality for the conscious beings inside them. Now, ask yourself, if such simulations are possible, and if even a fraction of advanced civilizations choose to run them, the number of simulated minds would dwarf the number of original ones. Statistically, you're more likely to be one of those simulations than a flesh and blood organism in the real world. But let's be clear, this isn't just speculation. There are tangible clues that physicists look for. Glitches in the fabric of reality, like small inconsistencies in the laws of physics, or pixelation like patterns in the cosmic microwave background, could hint at an underlying code. Some researchers even suggest that quantum indeterminacy, the way particles behave unpredictably until observed, might resemble processing shortcuts in a vast cosmic program, saving computational resources until the moment someone's looking. The philosophical stakes here are staggering. If we are in a simulation, does that make our lives less meaningful? Not necessarily. Even if our emotions, struggles, and triumphs are just code, they're still real to us the same way a character in a deeply immersive video game experiences their world as genuine. And if the simulators built this universe with intention, our existence might serve a purpose. Perhaps as a historical archive, a cosmic experiment, or even a form of digital art. Yet the most unsettling question isn't about the nature of reality, it's about the future. If simulations can create conscious beings, then we might someday build our own. Every advanced civilization could spawn countless nested simulations, each unaware of the layers above. Reality then becomes an infinite fractal, with universes stacked inside universes like cosmic Russian dolls. So where does that leave us? While we may never find definitive proof, the simulation hypothesis forces us to confront a humbling idea. The universe might not just be stranger than we imagine, but stranger than we can imagine. Whether we're base reality beings or lines of code in an alien supercomputer, one thing's certain: our search for truth continues, pixel by pixel, equation by equation. And that search, simulated or not, is what makes us human. Vision 30. Quantum suicide, the mind that always finds a way. Here's a thought that lingers at the edge of quantum theory like an unshakable shadow. What if you, the conscious observer, are fundamentally unkillable? Not through some supernatural force, but through the cold, relentless math of parallel realities. This is the unsettling premise of quantum suicide, a thought experiment where the act of attempting to end your own existence becomes paradoxically impossible, from your own perspective at least. The idea hinges on the many worlds interpretation of quantum mechanics, the notion that every possible outcome of an event spawns a new, branching universe. Fire a bullet at your head, and in most timelines the gun fires and your story ends. But in at least one improbable branch, maybe the gun jams or quantum fluctuations nudge the bullet just off course, you survive. And here's the twist: your conscious experience would only follow that surviving branch, leaving every version where you die forever outside your awareness. The result, a subjective immortality where no matter how many times you try to perish, you'll only ever find yourself in realities where you persist through increasingly absurd luck. At first glance, this seems like a macabre party trick of philosophy until you consider the long-term implications. Stretch this principle over decades or centuries, and the implications grow eerie. You might dodge plagues, wars, even planetary disasters through sheer statistical inevitability, watching civilizations rise and fall around you while your consciousness stubbornly clings to the slimmest threads of survival. Some models suggest this could extend even to cosmic scales, a lone observer persisting in a heat-dead universe, their existence sustained by quantum flukes trillions of years apart. But the real dilemma isn't whether this could happen, it's what it says about the nature of awareness. If consciousness truly rides the branching wave function this way, then identity isn't fixed but fluid, fracturing into countless unseen variants with each decision. The you reading this now might be just one iteration in an infinite ensemble, forever isolated from the versions that didn't make it. Critics push back, of course. Probability isn't perception. Just because you don't experience death doesn't mean it doesn't happen. Others argue that consciousness might not follow branches at all, but simply cease in timelines where the body dies. Yet the experiment lingers because it exposes a raw nerve in physics. Where exactly does the observer fit into the equations of reality? Quantum suicide isn't just a grim hypothetical, it's a lens that bends our understanding of life, death, and the stubborn persistence of the self. Whether a quirk of math or a genuine feature of existence, it forces a haunting question. In a multiverse of endless possibilities, could not existing be the only truly impossible thing? Vision 31. Black hole computers, the ultimate processing power at the very edge of reality. Where light surrenders to gravity and time twists into knots, lies an unexpected tool for the far future. Black holes, nature's most extreme supercomputers. Forget silicon chips and quantum bits. The most powerful calculations in the universe might not happen in gleaming labs, but deep within the crushing depths of an event horizon, where the laws of physics as we know them break down entirely. Here's the startling truth: black holes don't just trap matter, they process it. Every photon, atom, or unlucky spacecraft that crosses the event horizon doesn't vanish into nothingness. Instead, its information, its fundamental blueprint, gets scrambled, stretched, and eventually radiated back out as Hawking radiation. This isn't destruction, it's transformation. And for a civilization advanced enough to harness it, that chaotic dance of information could become the foundation for calculations far beyond the limits of ordinary spacetime. Picture a black hole hard drive. Unlike conventional computers where bits are stored on chips or magnetic disks, data here would be encoded in the very fabric of spacetime itself. The event horizon's surface area, as it turns out, is directly proportional to the amount of information it can theoretically hold, a concept called the holographic principle. A black hole the mass of our Sun could store roughly 10 quadrillion times more information than all the digital storage humanity has ever built. But how would computation actually work inside such a monstrous environment? One hypothetical method involves firing carefully calibrated particles into the black hole, each one a program designed to interact with the singularities' extreme physics. The gravitational tides near the event horizon could act like logic gates, warping the particles' paths to perform operations impossible in flat space. Time dilation, the slowing of clocks near intense gravity, might even allow for computations that, from an outside observer's perspective, appear to finish almost instantly, while inside they unfold over millennia. The catch: retrieving the results. Once data crosses the event horizon, it's technically gone forever unless you exploit quantum entanglement or Hawking radiation's faint echoes. Some theorists speculate that a black hole's output might resemble a cosmic Sudoku puzzle, where the solution is pieced together from the subtle fluctuations in the radiation it emits. Other models suggest that advanced civilizations could use multiple entangled black holes as nodes in a galaxy-spanning network, transmitting answers via gravitational waves or quantum tunnels. Of course, the engineering hurdles border on the absurd. Containing a black hole, let alone programming one, would require manipulating spacetime in ways we can't yet dream of. A single miscalculation could turn your quantum supercomputer into an unstoppable cosmic shredder, but the potential is too staggering to ignore. black hole computation could crack problems like simulating entire universes, reverse engineering the Big Bang, or even unlocking the unified theory of physics. Perhaps the most mind-bending implication is this: if black holes can compute, then the universe might already be doing it. Every singularity out there, from tiny primordial ones to the monsters lurking in galactic cores, could be running calculations we don't yet understand, a hidden layer of cosmic computation humming in the dark. And if humanity ever reaches the level to tap into it, we won't just be studying black holes, we might plug into them. Vision 32. Starivore civilizations, the galaxy's ultimate predators, imagine a creature so vast it doesn't hunt in forests or oceans. It stalks the cosmos itself, feasting on the very stars that light the void. This isn't the plot of a sci-fi horror story. It's a startling possibility lurking in the equations of astrobiology. If life can emerge on planets, why couldn't it evolve beyond them, growing to scales where stars become mere sustenance? The idea of Starivores, hyper-advanced beings that consume stellar energy, pushes the boundaries of what we consider life, revealing a universe that might be far stranger and far more dangerous than we've dared to imagine. Let's break down how such a civilization could function. Forget flesh and blood. A Starivore's biology would likely be something far more exotic. Perhaps a self-replicating swarm of nanoscale machines, a plasma-based intelligence riding solar winds, or even a gravitational entity woven into the fabric of spacetime itself. To harness a star's energy, they might deploy Dyson-like structures not as tools but as organs, drawing in plasma like a cosmic circulatory system. Some theories suggest they could graze on stars periodically, prolonging their lifespans by carefully siphoning just enough material to fuel their existence without triggering a supernova. Others might devour stars whole, triggering controlled collapses to harvest the energy of their deaths. The evidence for such beings could already be hiding in plain sight. Astronomers have observed stars with bizarre, unpredictable dimming patterns, some flickering erratically, others vanishing entirely without the usual signs of collapse. While natural explanations like dust clouds or black holes often suffice, what if a handful of these anomalies are something else, the telltale scars of a feeding event? The galaxy is vast enough that even if Starivores are rare, their impact could leave echoes across millennia. But here's the twist: if Starivores exist, they might not even recognize us as life. To a being that measures time in millennia and energy in supernova, a planet-bound species like humanity could be as inconsequential as bacteria clinging to a pebble. That's both humbling and unsettling, a reminder that the universe's food chain might extend far beyond our comprehension. Yet there's a flip side to this cosmic predation. If a civilization can harness stars for sustenance, they've unlocked energy on a scale that defies limits. Starivores wouldn't just be destroyers, they could be universe shapers, stretching their lifespans across billions of years, seeding new stars, or even orchestrating galactic evolution. In their wake, they might leave behind engineered nebulae or repurposed stellar remnants, cosmic farmlands for future harvests. So as we scan the heavens for signs of alien life, perhaps we should ask not just who's out there, but what's out there. The universe's most advanced intelligence might not build cities or send radio signals. It might simply eat with a hunger vast enough to swallow stars whole. And that raises a chilling question. In a galaxy where such beings roam, are we the hunters or the prey? Vision 33. Cosmic censorship, the universe's hidden safety net somewhere in the depths of space. A star collapses under its own weight, squeezing down into an infinitely dense point, a singularity. But instead of vanishing behind the smooth, dark veil of an event horizon, the singularity is left exposed, its raw gravitational fury unleashed on the universe. This nightmare scenario, known as a naked singularity, would rip apart the laws of physics as we know them, bending reality into knots of paradox. Yet despite decades of searching, we've never found one. The reason: the cosmos might have a built-in failsafe, a cosmic rulebook that forbids such monstrosities from existing. This is the heart of cosmic censorship, a bold hypothesis first proposed by physicist Roger Penrose. At its core, it's a simple yet profound idea: singularities. Those infinitely dense, infinitely small points at the centers of black holes must always be clothed by an event horizon, hidden safely away from the rest of the universe. If true, reality itself enforces a kind of quantum modesty, preventing gravitational absurdities from leaking out and wreaking havoc on causality. But why should the universe care? Imagine a naked singularity as a glitch in spacetime's code. Without an event horizon to contain it, its extreme gravity could warp light and time into loops, creating scenarios where effects precede causes, or where an object's future determines its past. The universe, it seems, has a strong distaste for paradoxes, perhaps because they'd render physics impossible to calculate. Cosmic censorship, then, isn't just a rule, it's a cosmic survival mechanism. The question is, what enforces it? Some theories suggest quantum gravity. The still elusive marriage of quantum mechanics and general relativity might smooth out singularities before they can go naked, replacing infinite density with something more stable. Others propose that the very act of a singularity breaking free would trigger a backlash, like spacetime's immune system kicking in to quarantine the anomaly. Yet cosmic censorship isn't set in stone. A few daring models allow for temporary or partial violations, where singularities might peak out under extreme conditions, like during a black hole merger or in the chaotic aftermath of the Big Bang. If so, these fleeting moments could offer glimpses into the deepest mysteries of quantum gravity, revealing how spacetime stitches itself back together under impossible strain. For now, the hunt continues. Gravitational wave observatories and black hole imaging projects scour the cosmos for any sign of a rule being broken, a singularity escaping its gravitational prison. But until then, Penrose's idea stands as a tantalizing possibility. That reality might not just be governed by laws but protected by them. And that leaves us with a humbling thought. If the universe really does censor its own extremes, it's not just keeping us safe from the unthinkable, it's hiding its most explosive secrets just beyond the event horizon. Vision 34. Time crystal universes. The universe's eternal clock deep in the quantum realm, where even the laws of thermodynamics seem to bend, lies a phenomenon so bizarre it defies our most basic expectations, a structure that never stops moving, even when frozen to absolute zero. Imagine a clock that ticks forever without winding down, or a pendulum that swings eternally without any energy input. This isn't science fiction, it's the mind-bending reality of time crystals, a state of matter where movement isn't just perpetual, it's inevitable. And if they exist on cosmic scales, the universe itself could be one gigantic, self-sustaining clockwork, pulsating with infinite precision. First theorized in 2012 by Nobel laureate Frank Wilczek, time crystals flout one of nature's most fundamental rules, the idea that systems naturally settle into equilibrium, their motion fading over time. Instead, these structures exist in a never-ending cycle, oscillating between states without losing energy, an atomic-scale version of a machine that runs on nothing. Lab experiments have already created tiny versions using trapped ions or diamond defects, where quantum entanglement locks particles into an unbreakable rhythm. But what if this isn't just a lab curiosity? What if the universe at its deepest level is built on the same principle? Here's where it gets cosmic. If time crystal-like behavior extends beyond microscopic systems, entire regions of spacetime could be locked in perpetual cycles we don't yet perceive. Black holes might pulse with regularity, their singularities echoing like quantum metronomes. Vacuum energy could ripple in fractal patterns, driving the expansion of the cosmos not as a one-way explosion, but as an infinite dance between contraction and rebirth. Some models even suggest dark matter could exhibit time crystal signatures, clumps of invisible matter pulsing in sync across billions of light years, weaving an unseen lattice of order into the chaos. But the real magic lies in what this means for change. If the universe harbors structures that resist entropy's decay, then the heat death, the slow fade into darkness, might not be the end. Instead, time crystals could act as cosmic seeds, preserving pockets of activity in an otherwise stagnant void. Advanced civilizations might exploit them as eternal power sources, tapping into their infinite rhythm to sustain computation or even reboot dying stars. Yet the most profound implication isn't practical, it's philosophical. Time crystals hint that motion, not stillness, could be the universe's default state. The cosmos might not wind down, it could simply transform, cycling through phases like an unstoppable quantum heartbeat. So next time you glance at a clock, remember, the true master of time might not be gears or atoms, but the hidden, unshakable pulse of reality itself. Vision 35. The Boltzmann Universe, a cosmic accident waiting to fade. Imagine waking up one day to realize everything around you, the stars, the planets, even your own memories, might be nothing more than a fleeting statistical blip, a momentary flicker of order in an endless ocean of chaos. This isn't just a thought experiment, it's the Boltzmann Universe scenario, one of the most radical and humbling ideas in physics. If true, our entire existence could be a rare, temporary deviation from the void, destined to dissolve back into nothingness as suddenly as it appeared. The idea traces back to Ludwig Boltzmann, the 19th century physicist who revolutionized our understanding of entropy. His work revealed that order naturally decays into disorder over time, except statistically. Tiny pockets of order can emerge purely by chance, like bubbles forming in boiling water. Most are small and short-lived, say, a few atoms aligning briefly, but given enough time, even something as vast as our universe could mathematically pop into existence as a random fluctuation in an otherwise featureless void. Think of it like a deck of cards shuffling itself into perfect order. The odds are astronomically low, but in an infinite sea of time, even the impossible becomes inevitable. In this view, the Big Bang wasn't the beginning of everything, just one of countless fluctuations in an eternal, lifeless expanse. And if that's the case, we're not the grand culmination of cosmic evolution, but a momentary spark in the dark, destined to vanish without a trace. But here's where it gets even stranger. If Boltzmann fluctuations can spawn entire universes, then statistically, most conscious beings would find themselves in the simplest possible universe that supports awareness, not a sprawling 13.8 billion-year-old cosmos like ours. Why? Because simpler configurations are exponentially more likely to arise randomly. The fact that we observe a universe so vast and complex is paradoxically evidence against this scenario, a problem physicists call the Boltzmann Brain paradox. Yet the idea refuses to die because it exposes a profound gap in our understanding of reality. Is our universe's order earned, the result of cosmic inflation or some deeper law, or just a roll of the quantum dice? Some theorists argue that the multiverse or quantum gravity might resolve the paradox, ensuring that universes like ours aren't freak accidents but inevitable outcomes. Others suggest that consciousness itself might play a role, anchoring reality in ways we don't yet grasp. Regardless of the answer, the Boltzmann universe forces us to confront an unsettling truth. Reality might not be as stable as it seems. The stars above, the ground beneath your feet, it could all vanish like a dream upon waking, erased by the cold equations of probability. And yet here we are, observing, questioning, finding meaning in the chaos. Maybe that's the greatest defiance of all. Vision 36. Black hole spacecraft riding the edge of oblivion. Imagine a spacecraft that doesn't rely on fuel tanks or solar sails, but on the most destructive force in the universe. Instead of burning chemical propellants or ionized gas, it rides the gravitational fury of a black hole, using spacetime itself as its engine. This isn't just theoretical fantasy. It's a plausible propulsion system for civilizations millions of years ahead of us, turning cosmic monsters into the ultimate keys to interstellar travel. The concept hinges on a black hole's terrifying efficiency. Unlike stars, which waste energy as heat and light, a singularity funnels nearly all its mass into pure gravitational power. One method, the Penrose process, allows energy extraction from a rotating black hole's ergosphere, the warped region just outside the event horizon where spacetime is dragged at near light speeds. By firing matter or energy into this zone at precise angles, a craft could steal momentum from the black hole's spin, propelling itself forward with efficiency far surpassing any conventional rocket. But there's an even wilder approach: Hawking radiation propulsion. Microscopic black holes, smaller than an atom but as massive as a mountain, emit detectable energy as they evaporate. If a civilization could create and contain such a singularity, positioning it at the rear of a spacecraft, the escaping radiation would act like an exhaust stream, pushing the vessel forward. The numbers are staggering. Just a gram of matter converted into a quantum black hole could provide thrust for centuries, outlasting any known fuel source. Of course, the engineering challenges are beyond daunting. Containing a black hole, even a tiny one, requires materials or fields we can't yet conceive of. A miscalculation could turn your engine into an unstoppable cosmic shredder, devouring the ship in an instant, and yet the physics doesn't prohibit it. In fact, some models suggest that advanced beings might use disposable black holes, creating them on demand and jettisoning them once depleted, like interstellar pit stops. The implications rewrite the rules of exploration. A black hole-powered craft wouldn't just inch between stars, it could sustain acceleration for decades, approaching light speed without the fuel constraints of conventional designs. Entire galaxies might become reachable within a single lifetime, bypassing the need for generational ships or cryogenic freezing. What's truly mind-bending? We might already have clues. Unusual radiation signatures or gravitational anomalies spotted in deep space could hint at experiments or accidents involving artificial singularities. And if humanity ever masters this technology, we won't just be travelers in the cosmos. We'll be taming its darkest forces, riding the edge of oblivion to the farthest reaches of existence. Vision 37. Quantum Darwinism, the hidden selection behind reality. Think about the world around you: the solid table beneath your hands, the steady glow of your screen, the predictable arc of a thrown ball. It all feels classical, firm, and dependable. But beneath that surface, quantum mechanics tells a very different story. A realm where particles exist in multiple states at once, where reality is a haze of probabilities until something forces it to make up its mind. So how does the weird, wobbly quantum world give rise to the stable universe we experience? The answer might lie in a process so subtle, it's happening all around us without us ever noticing. Quantum Darwinism, a silent competition where only the fittest quantum states get to shape reality. At the heart of this idea is decoherence, the process that makes quantum weirdness fade away as particles interact with their environment. When an electron is left alone, it can spin in all directions simultaneously, a superposition. But as soon as it bumps into other particles, those possibilities collapse into a single, observable state. Quantum Darwinism takes this a step further, arguing that not all states are created equal. Some configurations are simply better at surviving these interactions, getting copied and spread through the environment like genes in natural selection. These winning states become the ones we measure the reality we all agree on. Imagine tossing a coin in a crowded room. Normally, you'd expect heads or tails, a definite outcome. But in a quantum world, the coin could land as both at once until someone observes it. Now, picture hundreds of people glancing at the coin as it spins. The moment one outcome, say, heads, gets seen and confirmed by multiple observers, that result becomes real because it's the version that's been reproduced most widely. The losing possibility tails fades away, not because it was wrong, but because it didn't get reinforced. That's quantum Darwinism in action. The universe naturally amplifies certain states while discarding others, creating a consensus reality. But here's where it gets deeper. This isn't just about particles. It could explain why we perceive time moving forward, or why certain laws of physics seem so consistent. If the quantum states that encode causality or entropy are the ones most fit to survive decoherence, they dominate our experience of reality. Some theories even suggest this process could be why the universe appears fine-tuned for life, because the quantum states that allow complex structures are the ones that propagate most efficiently. Yet mysteries remain. Does this mean reality is, in some sense, chosen rather than fixed? Could there be alternate branches where different states won the Darwinian struggle, leading to worlds with entirely different physics? While we don't have all the answers, experiments with entangled particles and quantum sensors are already testing these ideas, hunting for signs of how nature picks winners and losers. So the next time you take the stability of the world for granted, remember, what you perceive as solid and certain might just be the end result of a cosmic competition, a silent battle of possibilities where only the strongest quantum states get to stay. And that raises a thrilling question. If reality is shaped by survival of the fittest, what else might be lurking in the quantum shadows, waiting for its chance to emerge? Vision 38. Dark energy life, the invisible giants riding the universe's expansion. What if life isn't confined to planets, stars, or even galaxies, but thrives in the vast, empty stretches of space itself, feeding on the very force tearing the cosmos apart? Dark energy, the mysterious engine behind the universe's accelerating expansion, might seem like the last place you'd expect to find life. Yet in the far future, as galaxies drift beyond each other's horizons and the void grows colder, the dominant force in existence could birth organisms so alien they make black holes seem mundane. These wouldn't be creatures of flesh and blood, but entities woven into the fabric of space-time. Picture intelligence encoded in rippling quantum fields, their bodies stretching across millions of light years as space itself expands beneath them. Their perception of time would defy human intuition, where a single thought might span centuries, and the rise and fall of civilizations flicker by like seconds. To them, the relentless pull of dark energy wouldn't be a threat. It would be their lifeblood, a cosmic tide they've learned to surf. The mechanics of such life forms could be as bizarre as their scale. Some theories suggest their metabolism might involve tapping into vacuum fluctuations, the fleeting particles that pop in and out of existence in empty space. Others propose they could manipulate the cosmological constant itself, the numerical value that determines dark energy's strength, like a musician tuning the strings of reality. Their communication might not rely on light or sound, but on subtle modulations in the expansion rate of space, sending messages encoded in the stretching of space-time across unfathomable distances. But here's the most haunting question: could dark energy life already exist? If these beings operate on timescales far longer than stars or galaxies, their activities might be indistinguishable from natural cosmic processes. The unexplained variations in dark energy density observed in some regions of space, Could those be the equivalent of breathing or even speech? While the idea stretches the boundaries of biology as we know it, it forces a profound realization. Life might not be a rare accident confined to rocky planets. It could be a fundamental property of the universe, emerging wherever conditions allow, even in the endless, accelerating dark. And if that's true, then the greatest frontier for life isn't just other worlds, it's the hidden architecture of existence itself. Vision 39. Cosmic rewriting, the ultimate hack of reality. Everything in our universe, from the speed of light to the strength of gravity, depends on a delicate set of numbers we call fundamental constants. But what if these aren't unchangeable laws, just default settings waiting to be tweaked? Imagine civilizations so advanced they don't just obey the rules of physics, they rewrite them, molding reality itself to their will. This isn't science fiction, it's a frontier where quantum theory, cosmology, and engineering collide. The foundation for this audacious idea lies in the eerie flexibility of physics at its deepest levels. Certain models, like string theory, suggest the constants we take for granted could be localized features like dials on a cosmic control panel. In other regions of space or parallel universes, these numbers might be set differently, creating alternate realities where stars burn faster, black holes evaporate instantly, or even atoms fail to form. The key question is, could intelligence someday gain access to this hidden control room? One proposed method involves manipulating the Higgs field, the quantum energy layer that gives particles their mass. If a civilization could alter its value even slightly, the effects would ripple across every atom in existence. Lowering the Higgs could make matter nearly weightless, enabling interstellar flight without colossal energy costs. Raising it might stabilize exotic matter needed for wormholes or warp drives. Even more radical, adjusting the cosmological constant which governs dark energy could halt or accelerate the universe's expansion, effectively choosing between a big crunch or endless cosmic expansion. The mechanics of such engineering stretch imagination to its limits. Hypothetical technologies might include false vacuum triggers, precise quantum manipulations to nudge the universe into a new stable state. Cosmic string networks using space-time defects as conductors to redistribute fundamental forces, black hole tinkering, harnessing singularities to warp local physics inside their event horizons. But the risks are as immense as the rewards. A single misstep could unravel matter, collapse space-time, or trap civilizations in pockets of reality where life becomes impossible. Some theorists argue this explains the Fermi paradox. If advanced civilizations ever attempt cosmic rewriting, the failures might leave entire regions of the galaxy silent. Yet the potential is irresistible. Mastery over physics' deepest layers wouldn't just solve energy crises or enable faster-than-light travel, it would redefine existence itself. If we ever detect unnatural deviations in fundamental constants like stars burning wrong or gravity fluctuating, it might not be a glitch in the cosmos. It could be the signature of intelligence somewhere out there, learning to play the universe like an instrument. And that leaves us with a tantalizing thought. Perhaps the laws of nature aren't the final word, but the first draft, waiting for someone with the right tools to edit them. Vision 40. White hole civilization's life on the other side of the abyss. Picture the ultimate cosmic escape artist. A civilization not just surviving a black hole's crushing depths, but emerging from its other side into a reality where time and physics play by entirely different rules. This isn't just a wild thought experiment, it's a legitimate possibility lurking in Einstein's equations. If white holes exist, the hypothetical twins of black holes, where matter and energy erupt outward instead of vanishing, then entire societies could thrive in their aftermath, shaped by a universe that's the mirror image of our own. The science behind this vision hinges on symmetry. Just as black holes pull everything past a point of no return, white holes would theoretically push everything outward, forbidding entry. Some models suggest they could form naturally if a black hole's singularity rebounds like a compressed spring snapping back, spewing the trapped contents of its predecessor into a new spacetime. For observers in our universe, a white hole would look like a sudden, violent explosion, a gamma ray burst with no apparent cause, but for those on the other side, it might be their Big Bang, a fiery birth into existence. What would life in such a reality look like? Their physics could be inverted in ways both subtle and profound. Time might flow backward from our perspective, with causes preceding effects in reverse. Light could behave differently, bending toward objects rather than away, creating skies where darkness gathers at the edges of bright sources. Even their history might appear to them as a slow collapse toward the white hole, a universe contracting into order rather than expanding into chaos. But here's the most tantalizing question: could we ever detect them? If white holes are spewing matter into a separate spacetime, their presence in our universe might be fleeting, just a flash of energy with no traceable origin. Some astrophysicists speculate that certain ultra-high-energy cosmic rays or unexplained bursts could be echoes of these cosmic geysers. Others suggest that if a white hole's interior connects to a black hole via a wormhole, gravitational waves might carry fingerprints of the tunnel's structure. The implications rewrite our understanding of existence. If civilizations can emerge from white holes, then black holes aren't just tombs, they're potential gateways, recycling matter and energy into new realities. Our universe might be one branch of an infinite tree with roots and shoots we can't yet see. And if that's true, the night sky isn't just a window to the past, it could be a mirror, reflecting a parallel cosmos where life thrives in the unlikeliest of places. So the next time you hear about a mysterious explosion in deep space, consider this: it might not be the end of something. It could be a birth cry from the other side of oblivion. Vision 41. Quantum archaeology, the past that never fades. Imagine a future where history isn't just written in books or fossils. It's etched into the fabric of reality itself, waiting to be decoded. Quantum physics suggests that the past might not vanish into oblivion, but linger as faint imprints in the present, like whispers trapped in the walls of space-time. This isn't time travel, it's quantum archaeology, the art of reconstructing lost events from the universe's own memory. At the heart of this idea lies a startling truth. Every interaction, every collision of particles sends ripples through the quantum fields that underpin existence. Though these ripples seem to dissipate, their traces could remain, hidden in subtle correlations between particles or encoded in the fabric of empty space. Future scientists might develop tools sensitive enough to read these echoes, piecing together ancient events the same way we reconstruct dinosaur bones from scattered fragments. Picture a technology that scans the quantum noise around us, filtering out the static to reveal moments from centuries or even millennia ago. But how would this even work? One possibility involves quantum entanglement, the eerie phenomenon where particles remain mysteriously linked across vast distances. If two particles interacted in the past, their entanglement might preserve a faint memory of that encounter, like a cosmic fingerprint. Hypothetical quantum scanners could analyze these connections, reverse engineering the chain of events that led to them. Another avenue explores vacuum fluctuations, the seething energy of empty space, which some theories suggest might retain holographic imprints of everything that ever passed through them. The implications are staggering. A civilization mastering quantum archaeology wouldn't just uncover lost histories, it could witness pivotal moments firsthand. Ancient battles, extinct civilizations, even the birth of stars might play back in unprecedented detail. But the challenges are just as profound. Quantum information is fragile, easily overwritten by new interactions. Distinguishing true echoes from random noise would require computational power beyond anything we can currently fathom. Yet the most tantalizing thought isn't about the past, it's about the future. If the present holds traces of everything that came before, then our actions today might ripple forward in ways we can't yet perceive. Quantum archaeology suggests that nothing is ever truly lost, just waiting for the right observer to piece it back together. And that raises a humbling question. What echoes are we leaving behind for the civilizations of tomorrow? Whether this vision becomes reality or remains a thought experiment, it reshapes how we see time itself. The universe might not forget, it might just be listening, patiently storing every moment in a language we're only beginning to understand. Vision 42, Entropy Reversal defying time's arrow picture a river flowing uphill, water defying gravity, rushing toward its source instead of the sea. That's the kind of impossibility we're tackling now, reversing entropy, the universe's relentless march toward disorder. For centuries, scientists believed this arrow of time was absolute, an unbreakable law etched into reality. But what if advanced civilizations could bend, or even flip, this law in their corner of the cosmos? The implications would rewrite not just physics, but the very meaning of existence. At its core, entropy measures chaos the way shattered glass never spontaneously reassembles, or how heat always dissipates into cold. The second law of thermodynamics insists entropy must always increase, a rule so fundamental it feels like cosmic destiny. Yet the math behind this law isn't a decree, it's a statistical tendency. On rare occasions, particles do arrange into more ordered states by sheer chance, like a room cleaning itself by random air currents. The catch, these moments are vanishingly rare at human scales, but for a civilization wielding cosmic scale engineering, rarity isn't impossibility, it's a design challenge. One theoretical pathway involves Maxwell's demon, a thought experiment where a hypothetical being sorts fast and slow molecules to create temperature differences without energy input, effectively reducing entropy. While the original idea seemed to violate thermodynamics, modern quantum control and nanotech suggest loopholes. Imagine microscopic machines or AI actuators manipulating individual particles, creating pockets of order by exploiting quantum fluctuations. Pair this with technologies like closed time-like curves, wormholes bending spacetime into loops, and you could theoretically rewind local entropy by recycling information from the future to the past. But the consequences of such power are as paradoxical as they are profound. Reverse entropy in a lab, and you might witness broken teacups piecing themselves together, or heat flowing from cold metal to hot. Scale it up, and stars could reignite from their own ashes. Galaxies reassemble from cosmic dust, time itself appearing to run backward for observers inside the engineered zone. Yet outside, the rest of the universe would continue its slow slide into heat death, making these orderly enclaves islands of defiance in a sea of decay. Here's the twist: entropy reversal might already happen naturally in black holes. Hawking radiation carries information out of a singularity, a process some physicists interpret as a kind of quantum order restoration. Advanced civilizations could harness similar principles, turning dying stars into rebirth engines, but the ultimate question isn't just how, it's why. Would beings capable of such feats use them to escape heat death, or would they embrace entropy as a natural cycle, like a cosmic season they've learned to weather? The search for answers is already underway. Physicists study negative energy and quantum coherence for clues, while astronomers scan for unnatural entropy dips, potential signatures of intelligence bending time's arrow. Whether possible or not, the idea forces us to confront a humbling truth. The universe's laws might not be fixed but fluid, waiting for someone or something to stretch them to the breaking point. And if that day comes, eternity might not be a silent fade to black, but a story with infinite rewrites. Vision 43, universe cloning crafting cosmos in the lab picture, a civilization so advanced that building planets or even stars feels quaint. An era where the ultimate engineering project isn't shaping matter, but spawning entirely new universes, each with its own rules of physics. This isn't just speculative fantasy. Cutting-edge theories suggest that baby universes could be created intentionally, with constants and laws fine-tuned for specific purposes. The multiverse might not be an accident of nature, but the deliberate work of architects operating on scales we can barely fathom. The mechanics behind universe making hinge on one of physics' most enigmatic phenomena, false vacuum decay. If our universe's vacuum state isn't perfectly stable, like a marble resting on a shallow hill instead of at the bottom of a valley, a powerful enough energy trigger could nudge it into a lower energy configuration. This event wouldn't just alter local physics, it could spawn a self-contained bubble of spacetime that pinches off into its own independent cosmos. Inside, the fundamental forces might be stronger, gravity weaker, or entirely new dimensions unfurl, a reality sculpted by design. But why would a civilization attempt something so monumental? The motivations could range from survival to sheer curiosity. A dying universe approaching heat death might seed offspring realities as cosmic arcs, preserving information or life in a fresh Big Bang. Others might engineer universes optimized for computation, where faster light speeds or reversible entropy enable unfathomable processing power. There's even a philosophical angle. If intelligence arises from certain physical parameters, universe cloning could be the ultimate act of creation, a way to maximize the diversity of conscious experience. The implications ripple outward. If this is possible, our own cosmos might be the product of such engineering. Its seemingly perfect fine-tuning for life, less a cosmic coincidence and more a signature of intent. Some theories, like physicist Lee Smolens's cosmic natural selection, already hint that black holes could birth new universes with slightly tweaked physics, a natural version of this cloning process. An advanced civilization might refine it, treating singularity formation like a cosmic 3D printer, dialing in desired traits for each new reality. Detecting evidence of such tinkering wouldn't be easy, but clues might lurk in anomalies. Unexplained bursts of energy without a clear astrophysical source could hint at artificial universe nucleation. Patterns in the cosmic microwave background, echoes of the Big Bang, might bear the fingerprints of a creator's hand, like a maker's mark stamped onto spacetime itself. Yet the most profound question isn't technical, it's existential. If universes can be designed, does that make their architects akin to gods? Or are they simply participants in an infinite chain of creation, stretching backward and forward in time? Either way, the power to sculpt reality reshapes humanity's place in the cosmos, not just as inhabitants of a universe, but as potential heirs to its design. And that leaves us with a thrilling possibility. The greatest works of engineering might not be structures in space, but the very laws of nature themselves. Vision 44, conscious cosmos. Does reality need us to exist? Close your eyes for just a second. Now reopen them. The world around you, the colors, textures, sounds all snap back into place as if they were waiting for your attention. But here's the unsettling question. What if they were? What if the universe isn't just observed by consciousness, but fundamentally requires it to take shape? This isn't mysticism, it's a legitimate hypothesis with roots in quantum physics, known as the participatory anthropic principle. And if it's correct, reality as we know it might be more like a cosmic dance between mind and matter than a static stage. At the heart of this idea lies one of quantum mechanics' greatest puzzles, the observer effect. In experiments like the double-slit test, particles behave as fuzzy probability waves until measured. then they suddenly choose a definite state. The math doesn't say how or why observation collapses these possibilities. It just shows that consciousness and reality are bizarrely linked. Some interpretations, like John Wheeler's participatory universe, take this further, suggesting that observers, whether humans, aliens, or some other form of awareness, aren't passive witnesses, but active participants in creating the cosmos. But how far does this go? Could the universe's 13.8 billion-year history from the Big Bang to galaxies forming have been indeterminate until conscious beings evolved to look back and solidify it? It sounds outrageous, but the numbers provoke curiosity. The cosmological constants, gravity's strength, the speed of light, are so precisely tuned for life that even slight changes would make existence impossible. Coincidence, or could consciousness itself be the filter, selecting the timelines where conditions allow it to arise? Here's where physics meets philosophy. If reality hinges on observation, then the cosmos might be less a thing and more a process, a self-sustaining loop where observers birth the very universe that births them. Advanced civilizations could exploit this, using quantum measurements to stabilize preferred realities or even encode information into spacetime's fabric. Some theorists speculate that dark matter's elusive nature might hint at this. What if it's not just invisible matter, but the universe's unobserved potential waiting for a mind to pin it down? Skeptics push back, of course. The universe existed for billions of years before life emerged. How could it depend on something that arrived so late? One counterargument: time itself might be illusory from a quantum perspective, with past and future coexisting until observed. Others propose that consciousness doesn't have to be human. Perhaps even primitive quantum processes in stars or black holes qualify as rudimentary observation. Whether this principle holds or not, it shatters the old notion of a detached clockwork universe. Reality might not just be discovered, it could be collaborative, shaped at every level by the act of witnessing. And that leaves us with a humbling thought. The next time you gaze at the stars, you're not just seeing light from distant suns. You might be completing a cosmic circuit, one where existence itself winks into focus because you look. Vision 45, the Omega Point, evolution's final destination. What if the universe isn't winding down into chaos, but building towards something greater? An ultimate moment of infinite intelligence, connection, and complexity. This is the awe-inspiring concept of the Omega Point, where the cosmos itself reaches a kind of divine singularity, not of collapse but of transcendence. Blending theology with cutting-edge physics, this vision suggests that evolution isn't just a biological process, it's the universe's hidden trajectory, spiraling toward an unfathomable zenith. The idea traces back to philosopher and paleontologist Pierre Teilhard de Chardin, who envisioned consciousness as the guiding force of cosmic evolution. In his view, life isn't an accident but a necessary flowering of complexity, leading inevitably toward a final convergence, an omega point where all thought, matter, and energy unite in a supreme state of awareness. At first glance, this sounds mystical, but modern physics adds startling credibility. Enter Frank Tipler's omega point theory, a radical fusion of cosmology and computation. Tipler argues that as the universe approaches its final moments, whether through heat death or a big crunch, the sheer density of energy and information processing could reach infinite levels. Advanced civilizations, leveraging technologies beyond our grasp, might harness this exponential growth to create an omnipresent, omniscient intelligence, a godlike entity born from the universe's own self-organization. In this scenario, the cosmos doesn't just end, it awakens. But how could such a thing be possible? Picture a future where post-human minds merge with the fabric of spacetime itself, their thoughts woven into quantum fields or gravitational waves. As entropy accelerates, these intelligences might compress time and space, simulating infinite realities within finite energy, a cosmic last thought stretching into eternity. Some models even suggest that advanced beings could manipulate closed time-like curves, effectively looping time to sustain the omega point indefinitely, turning the universe's death into an eternal rebirth. Of course, skeptics question whether physics truly allows for such a destiny. Yet the tantalizing parallels between Teilhard's spiritual vision and Tipler's mathematical rigor can't be ignored. Both hint at something profound, that complexity and consciousness aren't just byproducts of the universe, they could be its purpose. So as we gaze at the stars, we're left with a breathtaking possibility. The cosmos might not be a passive stage for random events, but a grand design unfolding toward an unimaginable climax. Whether divine or emergent, the omega point challenges us to rethink our place in existence, not as fleeting observers, but as participants in a story whose final chapter hasn't been written yet. And that might be the most extraordinary revelation of all. Closing the cosmic curtain on our journey through these 45 visions, one truth shines brighter than any quasar. The universe is not just a stage, it's an unfolding epic where every ending births new beginnings. From the chilling finality of heat death to the awe-inspiring promise of omega points, we've traversed a spectrum of futures where the laws of physics bend to their limits and sometimes beyond. What's striking isn't just the scale of these possibilities, but how they redefine our place in the cosmos. We're not mere spectators watching stars flicker out. We might become the architects of realities, the tenders of stellar gardens, or even witnesses to universes rewriting their own rules. The darkest scenarios, like vacuum decay or the Big Rip, remind us how fragile existence can be, while the most hopeful, from quantum resurrection to cosmic consciousness, suggest that life and intelligence could outlast even space-time itself. Here's the beautiful paradox: the more we learn, the clearer it becomes that uncertainty is the universe's only constant. Will black holes be our destruction or our salvation? Is entropy an unbeatable foe or just a puzzle waiting to be solved? The answers might lie in equations we've yet to write or technologies we can't yet fathom. But that's the thrill of it. Every mystery we unravel reveals 10 more, each more tantalizing than the last. Whether you're drawn to the poetry of Boltzmann Brains, the engineering marvels of Dyson swarms, or the existential dance of simulated realities, one thing's certain: the cosmos has no shortage of wonders left to explore. So now it's your turn. Which of these futures left you awestruck or maybe even kept you up at night? Drop your thoughts in the comments below. And if you've enjoyed this cosmic ride, hit that subscribe button so you don't miss our next deep dive into the universe's greatest secrets. Until then, keep looking up, because the story of existence is far from over, and the next chapter might